Okay, good morning, everybody, and welcome to our Essentials for this class. Today, what we're going to do is we're going to talk about the lesson one, which we actually started yesterday. We looked at the quadrilaterals and their characteristics. So, just to kind of refresh your memory, quadrilaterals meaning it's a four-sided figure. Okay, so these are the stuff that's already on the notes on our up on our blog, but I just wanted to kind of refresh your memory. Quadrilaterals are anything that are four-sided figure, and they have different characteristics depending on which quadrilateral that we're talking about. So yesterday we focused on parallelogram, and these are their characteristics, how you describe their characteristics, and so on. Um, and then we went up to the rhombus yesterday. So my plan for today is to finish this lesson one, and then we can just move along, and then we'll have time to do some work. Okay, so let's this time here, because we are kind of familiar with some of the stuff that we're talking about from yesterday, so it's going to be a little bit faster. So and if you have any questions, feel free to send me an email. So here we go. So this is quite something that we are very familiar of, because we are already um, familiar with the shape of a rectangle. So a rectangle is a quadrilateral because it's a four-sided figure. Okay, so it's a special parallelogram. And what are their characteristics? So in terms of characteristics for a rectangle, it says what can we say about their side lengths? So side lengths, we know that this side, right? This side and this side are equal to each other. And then how do we explain those two? Well, these two sides are opposites of each other. Another thing that are equal to each other is this side up here and this side up here or down here. And those two are opposites of each other and they're equal. So we can say side lengths, opposite sides are equal. Now, this one here, it doesn't have a label on its vertices. Vertices are corner points. So, but if we were to put any vertices there, so we can say A, B, C, and D, we can say um, these two line segments are equal and these two line segments are equal. Okay, so let's do that. Let's just, we are very familiar with how we express things in geometry. So the vertices are labeled A, B, C, D. Um, and in this particular case, which opposite sides are equal? So we can say AC, this line segment AC, and then I put line above just to show that it's a line segment, is equal to line segment BD, like that. Okay. And what else are equal? Well, these two sides are equal. How do we express that or say that mathematically speaking, I guess? We can say AB, right there, this line here, is equal to CD. Okay, there you go. So that's that piece for this characteristic. What else are we talking about here? What about sides? Any sides parallel? Yesterday we said parallel means they're going in the same direction. So in this particular case, AC and BD are going in the same direction. They're going this way, right? So we can say opposite sides are parallel. Okay, now how do you say or write that opposite sides are parallel? Instead of writing this all of these things, we can say um, A AC, AC line segment, so we put a bar on top, is parallel. This is the symbol for parallel. As you can see, it's like two lines that are parallel to each other, which makes sense. Is parallel to BD, BD. That's that. And also here in this particular case, AB, I'm just going to put a comma there, AB line segment. So line segment AB is parallel to CD. So this is interesting because these two line segments, AC and BD, are both equal to each other and they're both parallel to each other. Okay. What else? What can we say? Can we say anything about perpendicular sides? Well, in this particular case, the word perpendicular means they create a 90-degree angle in between them. So any sides that are perpendicular. And this one here, we already have information that says that these are perpendicular to each other. We know that in a rectangle, it's 90 degrees in each corner there. Okay, so perpendicular sides, yes. Yeah. There are, yeah, yes, they are, we can say there are consecutive sides are perpendicular. Okay, we can't say opposite sides are perpendicular because they don't even touch each other. So we say consecutive. The word consecutive, yesterday we said it means that it's one after the other. So this line, okay, AC, the consecutive side would be this one. This is the next side to it. Okay, they make 90-degree angle right there. What about CD? CD, the consecutive side, it'd be a BD, right? Or a AC as well. They are perpendicular to each other, and then so on. So BD is perpendicular to AB. So those ones are perpendicular, and then we say consecutive. That means one after the other, one after the other. Now the symbol for perpendicular is actually very interesting because remember it makes the perpendicular symbol means like this, or the short way of like that. It's like an upside down T. So we can say AC. We can say, okay, an example here, and this is not the only one. We can say AC, line segment AC is perpendicular to, like that's an upside down T, okay, kind of looks like that. AC is perpendicular to CD, CD, like that. Okay, and yeah, that's just one example, and of course there's like 4 of them. Okay, so that's good. So we're learning some ways to write down. I'm gonna make it closer. Write down the, you know, the words. Okay, the opposite are equal. So we know equal sign, what that looks like. Parallel, we see the parallel symbol right there. And perpendicular, we got that perpendicular symbol. It's like an upside down T. Okay, so the next one, well, what about diagonals? Okay, so the diagonals are from one vertex to the, not the next vertex, but to the opposite vertex. So from here to there. So these are diagonals going diagonally. So are the diagonals congruent? And that particular case is yes. Yes, because remember, this is upright. It's not tilted to the side, so that makes diagonals are equal to each other. So are the diagonals congruent? Yes, diagonals are congruent. Congruent means they're equal to each other, right? They're equal to each other. So So what can we say? How do we describe that they're congruent to each other? How do we show that? We can say CB or BC, doesn't matter. If you want to start here to there, then that's okay. We can say line segment CB, CB, I said CB, okay, line segment CB. So this diagonal is congruent or equal to line segment AD, AD, okay? And these diagonals are just line from one vertex to the other. So that's a line segment. We put a line above there, okay? Any diagonals perpendicular. Perpendicular meaning do they make 90-degree angles here at the center? Okay, so I'm going to put a letter E at the center. Do they make a 90-degree right there? No. So here, in this upper angle here, it's going to be more than 90 degrees. And then this little angle right here on the side, this one is going to be less than 90. So any perpendicular diagonals are not perpendicular. Okay. And then what about these ones? Do the diagonals bisect each other? The word bisect means to cut into two parts, and then bisect is equally. So not just cutting it into two parts, but cutting it in a way that it's equal to both ends, both sides. So this diagonal in here actually cuts AD in equal parts. And this is really interesting because um, since A, since CB is cutting AD, it cuts AD into two equal parts. So this one and this one, right? AE is equals to ED. Now, what about AD? AD cuts CB in equal parts so that these two are equal. What's interesting is that these are equal to each other, right? So do diagonals bisect each other? Yes. Yes. Diagonals bisect each other. That means they cut each other into two equal parts. And then any size that are any angle size. So now focusing on angle size rather, angle sizes. Yes, we know that A and D are equal to each other. Opposite angles are equal to each other. These two are equal to each other. And in fact, all of them are equal to each other. So in this particular case, it's extra special because all angles at vertices are equal to 90 degrees. So angle D, so if you look at this angle D, it's 90 degrees. If you look at angle C, it's 90 degrees. Angle A is 90 and angle B is 90. Okay? So you can say angle A is equals to angle B is equals to angle C, which is equal to angle D, which is all of that equal to each other at 90 degrees each. Okay? So that's that. We're a little bit faster on that one. So let's go ahead to the next piece. Now this is even interesting because we are very familiar with the square. So what are the characteristics? Side lengths, any congruence, all sides are equal. Okay, so all sides are equal. That's just one L. Okay, so and as you can see, there's hash marks on each side. It's one hash mark on each side, so that means all four sides are equal. Parallel sides are sides parallel to each other. Yes, the opposite sides are parallel. Opposite sides are parallel. Okay, so we already know, we've already seen that one, so I'm not gonna bore you with extra detail. So we just know opposite sides are parallel. So this side is parallel to that side, and then this side on the top is parallel to the one at the bottom. Any perpendicular sides? Yes. Yeah, consecutive sides are perpendicular. Perpendicular. Okay, so that means one after the other. So this side here is perpendicular to the next one right there. Or you can go here. This is the side and it's perpendicular to this side. Are diagonals congruent? Okay, this is kind of interesting because if it's 90 degrees, there's no tilt on either side. So that means this diagonal here and this diagonal here are equal to each other. So diagonals are congruent. Yeah, diagonals are congruent. Okay, yes, they are. Okay. Are diagonals perpendicular? Yes. Okay, I didn't really specify that. Diagonals are perpendicular. I just said yes, and then let's take a look. So here's the diagonal right there, and then here's the diagonal right there. So our diagonals actually create this intersection right here, and if we measure this angle right here, it's going to be 90 degrees. If you measure this angle right there, it's another 90 degrees. So yes, diagonals are perpendicular. It's at 90 degrees here at the intersection. The next one, do the diagonals bisect each other? Yes, they do. So this diagonal in here, cut this other one equally. Okay, sorry. So there's two equal parts there. And then if I take this diagonal cuts the other one into two equal parts. And what's interesting about square is that these are equal to each other. As you can see, there's hash mark. So if I put an E at the center, so this and this, it's nice to always have the vertices labeled so we can't just say this and this are equal. So AE is equal to DE, which is also equal to CE and BE. BE. Okay. So diagonals bisect each other. And they don't bisect each other. Bisect each other. And they don't just bisect each other, like they are these four halves of diagonals are actually equal to each other. Okay, last bit, angle size. Angle size, any angles in this particular case, the angles at the vertices are equal to each other. Angles at vertices are equal to 90 degrees. Okay, so that's that. So we talked about different characteristics, and of course, we all of us know already about the sides and all that stuff. And there's other stuff that we just added on to what we know of. Okay. Okay, the next one that we're going to talk about is a kite. Okay, well, uh, I don't know about you, but kite is quite popular. Um, I guess toy. I don't know if it's popular still, but back in the olden days, we would fly kites, and especially on a windy day, it would just go up and up. But the kite kind of looks like this, right? So what are the characteristics of a kite? So kite is kind of different in a way. Okay, so I said side lengths are congruent. Okay, well, which side lengths are congruent? Not the opposite sides anymore, but the two consecutive sides are congruent. Okay, so we can just go A, B, C, and D, and then we're gonna put E at the center right there. Okay, so that we can easily state what's congruent. So side lengths means two consecutive sides are congruent, right? So these two are congruent and it's consecutive, one after the other. And then these two consecutive sides are congruent. So two pairs of consecutive consecutive means one after the other sides are congruent. Okay, so that means AB is equal to line segment AB is equal to AD. AD. Okay, next one. Any sides that are parallel? None. Like as you can see, these two sides, they're not going to go in the same direction. It's going to be, it's gonna get closer and closer together, so it's not going the same direction. So it's not parallel. And if you look at these two sides, then no. So no parallel sides. Parallel, no um, parallel sides. Okay. Perpendicular sides, anything that are perpendicular. Nope, nothing, right? Because this thing over here, AD and CD, they're not perpendicular to each other. It's gonna create an angle greater than 90 degrees. Okay, 90 degrees would be somewhere over here, but then this one's a little bit over. So no. And then this one is less than 90 degrees. So no. No sides, no perpendicular sides. Oops, should write down. No perpendicular sides. Any congruent diagonals? Okay. Well, if if you had this experience of creating a kite, we would, back when I was growing up, when we would make a kite, we make two sticks, this stick here and then this stick there, and then you'll see that this stick is longer than the other. So diagonals congruent. So this is a diagonal AC and this is the diagonal BD. They're not congruent. Like one diagonal is longer than the other. And then are the diagonals perpendicular? Okay, now that's interesting because when we create a kite, it's gonna be perpendicular right here at the center. So yes, diagonals are perpendicular. Are perpendicular. Okay. Do the diagonals bisect each other? Okay. So let's take a look. So this diagonal, okay, sorry, bring it down, you can't see that. Diagonal AC will bisect BD. BD. But diagonal BD will not bisect AC because when you look at this part here, AE is shorter than CE. So do diagonals bisect each other? We can say only one diagonal bisect the other diagonal. Okay, so it's not, they do not bisect each other. So because only one diagonal bisect the other one. Then last point here, angle sizes. Are any angles equal to each other? Any angles equal to each other? And in this particular case, like let's see here, angle B and angle D, sorry, bring it down. Angle B and angle D are equal to each other. These two are equal to each other. But angle A and angle C are not. So angle A, it will have to make it a little bit wider because it's a shorter side here. It has to make it wider to reach BD, whereas C, this is longer, so this is a smaller angle. So any angle size that are equal to each other, only one pair of angles, pair of opposite angles. You see that? Opposite angles are equal to each other. Okay, we don't have two pairs of opposite angles. We only have one pair of opposite angles. In this particular case, angle B is equals to angle D. So angle B, so that's this angle right there, and angle D, that angle right there, are equal to each other. Okay. Okay. Now, I before I move on to the next one, I just wanted to say that, when we say angle B, sometimes instead of saying angle B, other textbooks would actually say the vertices that's are enclosed in those vertices, the angle that are enclosed in the vertices. So we can say, other way of writing angle B here, angle B, we can say A, B, C. We can say other way of saying it's angle A, B, C is equal to, so that's the same thing as that one, are the same. And angle D, we can say angle D would be A, trace it out, so from A to D to C. So this angle right there, from A to D to C. So this is the angle ADC. So these two are the same. Okay, just a different way of writing it down. Okay, so that's that. So other way of writing things down. Good. So if you're joining us, we just did page 3. And we're going to go to page 4. Okay, so don't worry. I'm gonna post all of these online on our blog if you missed it. Okay, so we've looked at some of those special. Okay, let's back up again. We looked at some special parallelogram. We looked at rectangle. We looked at the square, and then we looked at the kite. Now we're going to take a look at the trapezoid. Trapezoids are those desks that we are sitting at sometimes at school, right? So trapezoid is still a four-sided figure. So it's still a quadrilateral. Quad means four. Lateral means side. So four-sided figure. Now this is kind of interesting. Okay. It's called isosceles trapezoid. Isosceles trapezoid. So wait a second. We said we saw isosceles before when we talked about triangle. So what does it mean, isosceles? We said in isosceles, two sides are equal. So it would look like this, right? It would look like this. Okay, no, it does. It's, like two sides are equal. So these two sides are equal. So these two are equal. So that's an isosceles triangle. Now, how do we make an isosceles trapezoid? So what you can do, how can that happen, is that we can chop the top. We can cut up this part here. Cut up that part right there. And yeah, I don't need to go that far. So this part, and this part, and then this part. Now we are looking at an isosceles trapezoid. If we cut this part in here that is parallel to this bottom piece, we're going to have this side still equal to this side, which is the same thing as that one. Okay, so what can we say about this one here? Side lengths, which ones are equal to each other, congruent? So I'll just call this vertices A or vertex A, B, C, and D. So in this particular case, which side lengths are equal? So it's going to be only one pair of opposite sides. Opposite sides are congruent. Okay, so it's only one pair. That would be only the AC equal to BD. So we can just say AC, okay, line segment equals to line segment BD. BD, like that. Okay, good. Any parallel sides? Okay, well, which two sides are parallel? These two sides are equal, but they're not parallel. What's parallel are these two, right? So parallel, as you can see, they use a symbol in here. That means they're going in the same direction. They're going in the same direction. They're parallel to each other. So we can say only one pair of opposite sides are parallel. Okay, only one pair of the opposite sides. So let's write that down. AB, line segment AB is parallel to CD. And you could actually see it on the picture that way. There you go. So we talked about any congruent sides, any parallel sides. Now let's take a look at any perpendicular sides, any perpendicular. So in this particular case, angle A is actually bigger than 90. Same thing with angle B. Angle C is less than 90. Angle D is less than 90. So in that particular case, no perpendicular sides. Okay, now what about here? Are diagonals congruent? Okay, this is interesting. Diagonals, and we didn't have the diagonals in here drawn, so we can draw a diagonal right there. Okay, I'm gonna just draw a diagonal CB and diagonal AD. Okay. Now, in this particular case, if we were to measure this one here, are diagonals congruent? Yes, diagonals are congruent. They're going to be equal to each other, congruent. So we can say diagonals AD is equal to CB. CB or BC, doesn't matter because the length from C to B is the same thing as from B to C. Okay, so it doesn't really matter. So from AD to CB, AD is equal to CB. Okay, so they are equal. Are diagonals perpendicular? Are diagonals perpendicular? Nope, they're not. They don't make 90 degrees on each side here, so no. Diagonals are not perpendicular. Okay, so they're not perpendicular. Do they bisect each other? That means, do they cut each other in half? You can see here, BC or CB, this is the diagonal. It actually doesn't cut AD in half, right? Because as you can see here, I'm going to put an E at the middle here. AE is shorter than DE. So it doesn't cut it in half, so no. No. Diagonals do not bisect each other. Like both of them. And any sizes that are equal to each other, in this particular case, an isosceles trapezoid, two pairs, so angle C, angle D are equal to each other, so as angle A and angle B are equal to each other. So how do we explain that? How do we describe that? So we can say two pairs of consecutive angles are equal. Okay, so which two pairs is that? So two pairs, so we can say angle C is equal to angle D. These two pairs are equal to each other. And angle A equals to angle B are equal to each other, right? Not the opposite, but the consecutive, two pairs of consecutive. So these two consecutive angles, and then these two consecutive angles. Okay, next one. This one is it's also trapezoid, but it's called right trapezoid. Okay, well, where did we see the right? Well, we looked at the right triangle before, but this is right trapezoid. So what's the deal with this one? So let's start off with right angle triangle. Right, so this is a right angle triangle right there. Now, what we can do is to make a trapezoid is to cut the top part of it. Okay, so cut this part out. As you can see, this is like Now, a four-sided figure and then one right angle right there. So that's why it's called a right, because it has a 90-degree angle in it and a trapezoid. Okay, so what does that mean? Side length. Any side lengths that are equal. Nope, none of them are equal. No side lengths are equal. I'll just put none. Doesn't matter. None. None of them are equal. So A, B, C, and D. So none. Like if you measure AB, it's not going to be the same thing as BD. It's not the same thing as AD, and it's not the same thing as CD. So none. Any sides that are parallel? Oh, okay. I see one pair of opposite sides are parallel. So one pair of opposite sides are parallel. Okay, so only AB is parallel. So this is a symbol for parallel to CD. CD. Anything perpendicular. Okay, only one consecutive sides are perpendicular. So only one. Okay, it's not opposite to each other, it's consecutive. One consecutive sides are perpendicular. Okay, so we can say AC is perpendicular to CD. Okay, so line segment AC is perpendicular to CD, and that's it. The other ones don't look like they're perpendicular. It's either they're too big or too small. Are diagonals congruent? Okay, let's draw a diagonal so we can see it. So diagonal CB and diagonal AD. Now can you see that this got stretched out further? So that means AD is longer than BC. So the two diagonals are not congruent. Not congruent. Are the diagonals perpendicular? So the only way that we can get a perpendicular diagonals if the opposite sides are equal, or if we have all sides are equal. So no, so diagonals are not perpendicular. Perpendicular. Do the diagonals bisect each other? Nope, because CB doesn't cut AD in half, right? Because here this is going to be shorter. AE is shorter than DE. So diagonals bisect each other, and the answer is no. Mhm. Last but not the least here, angle sizes. Any angles equal? None, right? Angle A is different from angle B, is different from angle C, is different from angle D, okay? If we add them all up, they're all going to add up to 360, but they're all different angles. Okay, so we look at the different properties, different characteristics. So properties is just a characteristic that describes a particular shape. Okay, so just like each of us have our own characteristics, so we can tell them apart. So now, this one is just a summary. I'm not going to go through this with you, but this is basically what we talked about. Okay, so just a summary. Example 1. Identify the statement that best describes a property of a rectangle. Okay, so identify the statement that best describes the property of a rectangle. So which one of these is a property or characteristic of rectangle? Okay, diagonals. Okay, let's just draw a rectangle here, just to kind of rough sketch of, what rectangle looks like. Okay, so just do a rough sketch of a rectangle. Diagonals of a rectangle are congruent. Okay, well, what are the diagonals? The diagonals is going from this way, that way. Okay, are they equal to each other? And the answer is yes. So this is yes. Diagonals has only one pair of parallel sides. Only one pair of parallel sides? No, it's actually two pairs. Two pairs. So this one should be 2. And that means a no, because that should be 2. 2 pairs. Diagonals of a rectangle bisect the interior angles. Oh, okay, so we didn't really quite talk about that, but diagonals of a rectangle bisect the inside angle. So what happens here is that if this is the interior angle, does it bisect? Means to cut into 2 equal parts. And the answer is no, because even if we just draw it out, and this is a diagonal, does it bisect this angle in here? You can see that this is smaller, and then this is bigger, which makes sense because here, this angle opens up to this side, which is shorter, and then this angle opens up to this side, which is longer. So it should be no. So diagonals bisect the interior angles. The answer is no. Do the diagonals of a rectangle meet at right angles? So here's where they meet. Do they meet at the right angles? No, not as well, because here this is more than 90 degrees and these are less than 90 degrees. So these are not 90 degrees in there. So the answer is no. So the only thing that best describes a rectangle is A. So this is the only thing. Okay, and we can just draw it out so we can have a visual and then understand the question there. Okay, we're on the very last page, and this is really, really interesting. This is where now some of the math comes in. So it says here, the following shape is a parallelogram. Okay, what does that mean by parallelogram again? Parallelogram means opposite sides are equal, opposite. Okay, let's go back to parallelogram. Okay, what's so special about parallelogram? Parallelogram has opposite sides are equal, and opposite angles are equal. Right there, opposite angles. Opposite sides are parallel. So a lot of equal stuff there, except for the diagonals, of course. So here, the following shape of a parallelogram. So parallelogram, if this is angle D is 115, what is the measure of angle A? Okay, well, this is interesting because we have no indication of what angle A looks like, but we'll see if we can figure it out. Okay, we know, what do we know? Angle D and angle B are equal. So we know opposite angles are equal, right? So we know angle D is equals to angle B, which that makes angle B 115 degrees. Well, uh, this is not the question though, right? The question is not what angle B is, which is angle A. Okay, this is interesting. We also know that angle A and angle C are equal. Angle A is also equal to angle C, which we have no idea at this time. So what do we know? What else do we know? We know that sum of angles is equal to how much? Sum of the angles, sorry, you can't see that. We know that the sum of the angles is equals to 360. Okay, so now let's see if we can figure it out. So we know that angle A, angle B, plus angle C, plus angle D is equals to 360. Yes, okay. We know angle B and angle D are 115. So this is going to be 115 plus 115. Angle A plus angle C is equals to 360 degrees. So what we can do is we can subtract 150, these two from both sides of the equation. So we know that angle A plus angle C. Okay, so subtract that. 360 minus 115 minus 115. Now we're left with 130 degrees. So angle A and angle C has to equal to 130 degrees. Okay, well, that's for those, but these two are equal to each other. So we can split the 130 in two equal halves. So 130 divided by 2. Okay, so that's going to be 65 degrees. Okay, so that means angle A is 65 here, angle C is 65 there. Okay, so we are looking at the characteristics of parallelogram to kind of figure out what's going on in here, and that's what we did. So this is 65 degrees. Okay, so this is where the math kind of comes along. Let's take a look at number 3, example 3. State the length of A. So this is side A right there, and angle B, which is right here, of a rhombus. Okay, now we know about rhombus. What do we know about rhombus? Rhombus is all four sides are equal. Rhombus, if this is a rhombus, that means this four sides are equal. So that one's easy. That means length A is 8 meters. 8 meters. Now, what else do we know? In terms of rhombus, we said opposite angles are equal. So opposite angles are equal. So that means if this is 50 degrees, then this is 50 degrees. This is also 50 degrees. Now it's kind of it's gonna be the same thing as the one above there. So we know that the four angles add up to 360. I'll just call them angle A here, B, C, and D, so we can do the math part there. We know opposite. We know opposite angles are equal. Okay, we're gonna shorthand this. We know opposite angles are equal, so that means angle A is equals to angle C, according to my diagram in here, because I labeled angle C there, is equals to 50 degrees, okay? And we also know that angle B and angle D are equal to each other. It's just that we don't know how much they are. We know too, we know sum of angles is equals to 360 degrees. So that means if we add up all the angles, angle A plus angle B plus angle C plus angle D is equals to 360. So angle A is 50, angle C is 50. We just don't know angle B and angle D. So what we could do is to subtract 50 on both, 100 basically, on both sides of the equation. So we're left with angle B and angle D. So we're left with 260. Okay, so subtract the 50 on each side of the equation to keep it balanced. And we know angle B and angle D are equal. So we can split these 260 into two equal sizes. So therefore 260 divided by 2, which is 130 degrees. So that makes this 130 degrees. So this is 130 and 130. Okay, that's great. We're in the very last one and we made it till the end of the class. It says here, justify why the following statement is false. Okay, well, the word justify means to make sure we state a reason why this is false. If a quadrilateral has one pair of parallel sides and one pair of congruent sides, then the quadrilateral must be a parallelogram. And then the answer is no, it's false, because a quadrilateral has to have two pairs. It needs to have two pairs of parallel sides and two pairs of congruent sides. So uh, a, this is false because a parallelogram must have two pairs of equal sides and two pairs of parallel sides. Hey, so we finished this this lesson today. So that would be it for today. I encourage you to try some of these or all of these questions, of course. The answers are at the back of the book, so make sure you're double checking the back to see that you've done everything correctly. I will be posting some of these questions online probably tomorrow. So I'll probably post question 6 and question 7, okay, because some of these have like calculation stuff. Okay, so there you have it. I want to say and take this opportunity to thank you for joining us in our class today, in our lesson. I want to remind you that we only have a few days left. We don't have a lot of days left. In this particular case, my goodness, we're almost done. We're like, and then I will, yeah, we only have basically just the polygons, and that's about it. So anyways, thank you very much for participating and for showing up and taking this time to learn. I wish you have a great day, and just email me if you have any questions. Okay, have a great day, everybody, and bye for now.